Phosphorus is an element that can come in a few different forms. One of the most reactive forms is white phosphorus, and a while ago, I was able to get some chunks of it. It's stored underwater to protect it from air, and the moment I take it out, it starts smoking. This is because it's reacting with oxygen and letting off phosphorus oxides. It's often used to make large amounts of smoke, but it's also sometimes used as a weapon, which is a bit terrifying. This is because white phosphorus is not only very toxic, it's also super hard to put out when it's on fire. To test this, I'm just going to light this small piece. It immediately starts burning and splashing, but I can put it out by just smothering it, which makes it seem not that bad. However, because it's so reactive with air, this is what happens when I take away the dish. So for no reason, I've decided to make some piranha solution, which is probably one of the angriest liquids that you can make in the lab. To do this, I just have to start with some concentrated sulfuric acid and then carefully add 30% hydrogen peroxide. It's important that I do this very carefully and to never add too much peroxide because it can actually become explosive. It also gets really hot and this mixture is able to destroy most organic things. I always find it fun to add stuff like paper to it because it just instantly turns it into carbon and then it vaporizes it into CO2 gas. In the past, I've also done it with things like a fortune cookie, and it was able to completely destroy it in seconds. I also did it on a much larger scale, and I was able to dissolve an entire hot dog, which was kind of terrifying. Over the last year, I've collected a small amount of gold powder, and I've decided to melt it down. To do this, it's actually quite easy, and I just have to put it all into a crucible and sprinkle on some borax. Then, if I blast it with a torch, it'll all eventually melt. I really thought I was going to be left with a super small bead, but this is actually pretty decent. It's barely just a gram, and at today's current price, it's worth about $52. So today, I'm going to be turning this dish into a silver mirror using some chemicals. To do this, I just need to add some water to a beaker and dissolve some silver nitrate. After that, I can pour in some ammonia solution, which causes some of the silver to separate out for just a second. The last ingredient is sodium hydroxide drain cleaner, and I need to wait for it all to dissolve. The solution's ready, but I only need 100 mils, so I'm gonna pour it into another beaker. To get the reaction started, I have to add some glucose, and I can now pour it onto the dish. It's already darkening because small particles of silver are separating out, and I just need to leave it like this for a while. This is 15 minutes later, and now when I pour off all the water and flip it over, there's a nice mirror on the back. So today, I'm going to be making some test tube rockets. To do this, I first need a really strong oxidizer, and I'm using pure nitric acid. Now, all I need to do is add a fuel to it, and I'm using something called aniline. This mixture of aniline and nitric acid was used in some of the first rockets, but nowadays, there are more efficient combinations. It's also common to use combinations that don't light on fire on their own, like liquid hydrogen with liquid oxygen. Here I have some gallium, and at room temperature, it's completely solid. However, it has a super low melting point of only about 30 C or 86 Fahrenheit. So, if I put it into a bowl of hot water, it should completely liquefy. It all eventually melted, and what I have now kind of looks like mercury. Unlike mercury though, it's not nearly as toxic, and it's much safer to hold in my hand. However, it is a lot messier, and it tends to stick to things and leave an annoying residue. What I have here is something called a cryo cooler, which sounds fancy, but it basically just gets really cold. To turn it on, I just need to flip this switch and turn the power dial just a bit. This causes the tip of it to start cooling down, and within a couple minutes, it starts causing moisture from the air to condense and freeze. That isn't too exciting though, and the fun part is when I add a thermos and wait a couple hours. It's now been like an hour and a half, and it kind of looks the same, but I've actually collected something in the thermos. The cryocooler gets down to something like -200°C, and it's cold enough to cause air to start condensing into a liquid. I honestly didn't think I was going to get much here, but I have over 25 mils of liquid air. So today, I've decided to make a really unstable chemical called manganese heptoxide. To do this, I just need to start with some sulfuric acid and then sprinkle on something called potassium permanganate. It makes this angry green liquid that can spontaneously decompose just by touching it. It also reacts with almost anything organic, and this is what it does to a cotton ball. It's even more violent with liquids, and this is what it does with ethanol and acetone. This is luminol. It's a chemical that exhibits something called chemiluminescence, and when it reacts, it can release light. To make this happen, I just have to add water to a beaker and a decent amount of sodium carbonate. Then I can add the luminol, which can dissolve in this solution. I also need to add some sodium bicarbonate, and this solution is basically ready. Now, I just need to make an iron solution by mixing together 3% hydrogen peroxide and something called potassium ferrocyanide. To make the luminol glow, I just have to mix these two solutions together.